For this problem, we're going to factor out the greatest common factor. We have a binomial to start with. 6x cubed y squared minus 36 x to the 7th power y cubed. We want to factor out the greatest common factor between each factor here. These things are multiplying each other, so they're all factors. When I look at the coefficients, I can think about the greatest common factor between 6 and 36, which is 6. We can start with 6. Now, when I look at the variables, I'm always going to be looking for the least value as far as my exponent goes. Think about it this way. If I have x cubed, that means I have x times x times x. If I have x to the 7th power, well then we have 7x's. And the greatest common factor would be how many of them are common between both of them. So there are 3 x's that are common. That means that x cubed would be our greatest common factor. And same thing with y. If I have y squared, that means I have y times y. And if I have y cubed, that means I have y times y times y. And the common 2 y's would be our greatest common factor. So y squared, it's our greatest common factor. So then our greatest common factor is 6x cubed y squared. Now we need to factor it out. That means that I can divide each term by the greatest common factor. So 6x cubed y squared divided by 6x cubed y squared. Anything over itself gives us 1. So this would be 1. Then we grab our second term and divide it by the greatest common factor. That'll be negative 36 x to the 7th power y cubed over 6x cubed y squared. Well, negative 36 divided by 6 gives us negative 6. We can apply our quotient rule with our variables with exponents. X to the 7th power over x cubed means that we can subtract the exponents. 7 minus 3. Well, 7 minus 3 is 4, so we get x to the 4th power. Let's apply the quotient rule for y. That means 3 minus 2 is 1. Y cubed over y squared gives us just y. So our remaining factor would be 1 minus 6 x to the 4th power and y. And this would be our final answer.